computer role as an additional set of general registers for complex code like a floating point arithmetics or home computer games. The duplicate register file is often referred to as the alternate register set by some. The primed register file, since the apostrophe character is used to denote them in assembler source code and the Zilog documentation. This emphasizes that only one set is addressable at any time. However, the 8-bit accumulator with its flag register F is bifurcated from the general-purpose register pairs HL, D and BC. This is accomplished with two separate instructions used to swap their accessibilities. XFF exchanges only register pair F with F, while the EXX instruction exchanges the three general-purpose register pairs HL, D and BC with their alternates HL, D and BC. Thus the accumulator can interact independently with any of the general-purpose 8-bit registers in the alternate, or primed, register file, or, if HL contains a pointer to memory, some byte there. D and BC can also transfer 8-bit data between memory and accumulator. This can become confusing for programmers because after executing XFF or EXX, what were previously the alternate, primed, registers are now the main registers, and vice versa. The only way for the programmer to tell which set, S, are in context, while playing computer while scrutinizing the assembler's source text, or worse, poring over code with a debugger, is to trace where each register swap is made at each point in the program. Obviously, if many jump and calls are made within these code segments, it can quickly become difficult to tell which register file is in context unless carefully commented. Thus it is advisable that exchange instructions be used directly and in short discrete code segments. The Zilog Z80 instruction set includes JAF and JAR instructions which jump to a destination address if the alternate registers are in context, thus officially recognizing this programming complication. Registers. Zilog Z80 registers 1513121130706050403030201010. Bit position, main register flags if, 8-bit accumulator and flags, BC, date and address register, DD, date and address register, HL, 16-bit accumulator and address register, alternate registers A flags F, 8-bit accumulator and flags, BC, date and address register, DD, date and address register, HL, 16-bit accumulator and. As on the 8080, 8-bit registers are typically paired to provide 16-bit versions. The 8080 compatible registers, 23, RF, 8-bit accumulator, A, and flag bits, F, carry, 0, minus, parity /overflow, half carry, used for BCD, and an add /subtract flag, usually called N, also for BCD. BC, 16-bit data /address register or two 8-bit registers. D, 16-bit data /address register or two 8-bit registers. HL, 16-bit accumulator /address register or two 8-bit registers. SP, stack pointer, 16 bits. PC, program counter, 16 bits. The new registers introduced with the Z80 are 9, 16-bit index or base register for 8-bit immediate offsets. IY, 16-bit index or base register for 8-bit immediate offsets. I, interrupt vector base register, 8 bits. R, drum refresh counter, 8 bits, MS does not count. F, alternate, or shadow, accumulator and flags, toggled in and out with XFF. BC, D and HL, alternate, or shadow, registers, toggled in and out with EXX. 4 bits of interrupt status and interrupt mode status. The refresh register are increments each time the CPU fetches an opcode, or an opcode prefix which internally executes like a 1-byte instruction. Address register, index register 6, index XIY, index USP, stack pointer, other registers, I interrupt vector, refresh counter, program counter, status register, SZHP /VNC flags. And has no simple relationship with program executable. This has sometimes been used to generate pseudorandom numbers in games, and also in software protection schemes. It has also been employed as a hardware counter in some designs. An example of this is the ZX81, which lets it keep track of character positions on the TV screen by triggering an interrupt at wraparound. By connecting in to a 6. The interrupt vector register, I, is used for the Z80 specific mode 2 interrupts, selected by the M2 instruction. It supplies the high byte of the perceived address for a 128 entry table of service routine addresses which are selected via an index sent off CPU during an interrupt acknowledge cycle. This index is simply the low byte part of the pointer to the tabulated indirect address pointing to vis-a-vis routine. 11. The pointer identifies a particular peripheral chip or peripheral function or event, where the chips are normally connected in a so-called daisy chain for priority resolution. Like a refresh register, this register has also sometimes been used creatively, in interrupt modes 0 and 1, or in a system not using interrupts. It can be used as simply another 8-bit data register. The instructions LDR and LDI affect the Z80 flags register, unlike all the other LD, load, instructions. The sign, bit 7, and 0, bit 6, flags are set according to the data loaded from the refresh or interrupt source registers. For both instructions, the parity /overflow flag, bit 2, is set according to the current state of the IFF2 flip-flop. 24, microarchitecture. Although the Z80 is generally considered an 8-bit CPU, it has a 4-bit ALU, so calculations were done in 2 cycles. 25, Z80 assembly language. Data point 2200 and Intel 8008. The first Intel 8008 assembly language was based on a very simple, but systematic, syntax inherited from data point 2200 design. This original syntax was later transformed into a new, somewhat more traditional, assembly language form for this same original 8008 chip. At about the same time, the new assembly language was also extended to accommodate the additional addressing modes in the more advanced Intel 8080 chip. The 8008 and 8080 shared a language subset without being binary compatible. However, the 8008 was binary compatible with the data point 2200. In this process, the mnemonic L, for load, was replaced by various abbreviations of the words load, store and move, intermixed with other symbolic letters. The mnemonic letter M, for memory, referenced by HL, was lifted out from within the instruction mnemonic to become a syntactically freestanding operand, while registers and combinations of registers became very inconsistently denoted, either abbreviated operands, MVID, LXIH and so on, within the instruction mnemonic itself, LDA, LHLD and so on, or both at the same time, LDXB, StarkSD and so on. Intel 8008 data point 2200 Intel 8080 Intel 8085 Zilog Z80 Intel 8086 / Intel 8088 before CA 1973 CA 197419761978 Kmuth BC LDB Kmuth BLC LDX BLD BC Namuth.
Yes, then the program just read all these weird numbers. this computer voice just read everything. So sometimes they have show some program codes. The program will just read all kind of weird numbers. Cheers. So now it's 10:40. Let's get a little bit, just continue in 2 minutes. Yes, now the sun is out and now it will getting hotter. It's 25, but I lost 23 kilos since last summer was 133. So I lost so this summer it will be me more easy to go through a hot summer because I lost more than 20 kilos of weight, but I'm still very heavy. I try to get below 100 kilos, so I cannot eat so much food the last rest of this year. So it will just read this weird numbers in few minutes. No, last summer I was 133 kilos. The 28th July last summer. Yes, last time that was 110 kilos. That was the 22 April last month. So I weighed me in 3 weeks, the 27. I just find I lose 1 kilo or 2 kilo, that's fine. No, I'm going to wait there. And we are, yes, that's the 12th, Thursday the 12th. So tomorrow, that's 2 weeks tomorrow. And I will get my YouTube money the 25. So, but I eat a little bit more food than I did like this month, and I did eat a little bit potato chips, and I was eating a little bit candy, but not much. But you cannot eat much if you like to lose weight. I don't exercise. That's just on diet. I'm just keeping a low number of calories. What do you say? Calories? What's inside the food? Calories. But I have been giving up a long time, many months ago. I'm giving up eating butter. I'm not eating butter anymore and stuff like that. And no Coca-Cola with sugar. Only drink without sugar. Yes, but now we have along many weird numbers. But this program just read everything. Continue.
MLD, HL, MOVL, BX, move BMLDB, HL, MOVBL, BX, dash stocks DLD, AL move MALD, HL, a move, BX, Orvik move MCLD, HL, Kloof, BX, Hudi 56 MVID 56 LDD 56 MOVDL 56 LMI 56 MVIM 56 LD, HL, 56 MOV byte PTR, BX, 56 LDA 1234 LDO, 1234, MOVL, 1234, STA 1234 LD, 1234, a move, 1234, LLDB, 9 plus 56, MOVBL, Psi plus 56, LD, 9 plus 56, Kloof, Psi plus 56, CLLD, IY plus 56, 78 MOV byte PTR, DI plus 56, 78 LXIB 1234 LDBC 1234 MOVCX 1234 LXIH 1234 LDHL 1234 MOVBX 1234 should 1234 LD 1234 remove 1234 BXLHLD 1234 LDHL, 1234 MOVBX 1234 LDBC 1234 MOVCX 1234 LD9 1234 MOVSci 1234. Illustration of 4 syntaxes, using samples of equivalent, or, for 8086, very similar, load and store instructions. 26. The Z80 syntax uses parentheses around an expression to indicate that the value should burst as a memory address, as mentioned below, while the 8086 syntax uses brackets instead of ordinary parentheses for this purpose. Both Z80 and 8086 use the AND sign to indicate that a constant is added to a base register to form an address. Note that the 8086 is not a complete superset of the Z80. BX is the only 8086 register pair that can be used as a pointer. New syntax. Because Intel claimed a copyright on their assembly mnemonics, 27, a new assembly syntax had to be developed for the Z80. This time a more systematic approach was used. All registers and register pairs are explicitly denoted by their full names. Parentheses are consistently used to indicate memory contents at constant address or variable pointer dereferencing, with the exception of one jump instruction JP, HL. JP, XY, is merely a variation of JP, HL, loading the new PC address. 11. All load and store instructions use the same mnemonic name, LD, for load, a return to the simplistic data point 2200 vocabulary. Other common instructions, such as add and inc, use the same mnemonic regardless of addressing mode or operand size. This is possible because the operands themselves carry enough information. These principles made it straightforward to find names and forms for all new Z80 instructions, as well as orthogonalizations of old ones, such as LDBC 1234. Apart from naming differences, and despite a certain discrepancy in basic register structure, the Z80 and 8086 syntax are virtually isomorphic for a large portion of instructions. Only quite superficial similarities, such as the word MOV, or the letter X, for extended register, exist between the 8080 and 8086 assembly languages, although 8080 programs can be translated to 8086 assembly language by translator programs. 29. 30. Instruction set and encoding. The Z80 uses 252 out of the available 256 codes as single byte of codes, root instruction, which are all inherited from the 8080. The 4 remaining codes are used extensively as opcode prefixes SAD smiley 31, CB and enable extra instructions, and DD or FD select 9 plus D or IY plus D respectively, in some cases without displacement D, in place of HL. This scheme gives the Z80 a large number of permutations of instructions and registers. Zilog categorizes these into 158 different instruction types, 78 of which are the same as those of the Intel 8080. 31. Allowing operation of all 8080 programs on a Z80. The Zilog documentation. 32. further groups instructions into the following categories, most from the 8080, others entirely new like the block and bit instructions, and others 8080 instructions with more versatile addressing modes, like the 16-bit loads, I/O, rotates/shifts and relative jumps load and exchange, block transfer and search, arithmetic and logical, rotate and shift, bit manipulation, set,